Right. You are officially on the PBE podcast, Stan.
Oh, so I'm allowed to wear my hat in this one?
Well, we're going to mostly be just recording the screen and talking about the geology of this wild place in San Antonio. So you are a little lizardy. Oh, speaking of lizardy, wait till you see this rock. Antigarite, lizardite, and
Chrysotile.
chrysotile.
Those are the three biggies in the serpentine group. That looks like a breccia. The upper part of the outcrop.
Huh. I'm surprised it doesn't let me zoom in. That's surprising. This is a weird rock. No question about it. Very strange. Doesn't help really with texture, but
Boy, it does really look like a serpentinite. Although the green clayish looking stuff in there,
yeah.
that's probably the mineral soladinite. It's a green clay, montmorillonite clay.
Oh, wow. So, yeah, we're trying to get XRF, XRD, rock eval, and all that stuff settled on this rock. What we do have is some rock eval stuff. We have some data to look at from previous studies with John Cooper, the president-elect with the South Texas Geologic Society. He's done, he discovered this.
So this is there an oil field here?
No, there's a golf course.
Yeah, but did they originally have it as a petroleum play and then
maybe I don't see any of that history anywhere, but it's possible back in the day.
Now what is the formational rock that this supposedly is?
This is supposedly Eagleford.
Wow, that's not your daddy's Eagleford. Boy, that is not your normal black shale.
No, sir. We'll have to get it crushed up, and we'll probably record another show next week on actually taking the samples and crushing them up and sending specifically what we want them to analyze. Our contact here is John Cooper. He's the current president-elect for STGS, and he's the undergrad that was looking for a job, and the industry was in bad shape. And the guy from Oxy.
Is his dad a geologist?
No. Wait a minute. No, I don't think so.
Because there was a famous, I don't even know if he's alive anymore, John Cooper, but he was a quadrangle mapper and a USGS guy.
Really?
He did a lot of stuff in southern Arizona, including around Sierra and
cool.
Texas Canyon.
Right on. No, I don't think that's his dad, but maybe related or something.
Silver. His name was John Cooper.
So, and remember, we're recording this now to jump into some details on maybe what's going on in Outcrop.
Okay, so it's on the northeast part of the loop there, the outer loop.
Yeah, and then downtown Riverwalk is right here.
Right.
And you come up out of there and you get to Olympia Hills. And when you come out of here, you're going up and down these features right here that are cutting across the freeway.
Where's the airport at?
Right here.
Oh, okay.
Yep. And so it's structurally very interesting when you start driving towards this part of town. You quickly elevate from downtown, like flatter, more rolly, large rolly kind of topography of San Antonio.
It's more hummocky.
Yes. Yep. It's like a big wrinkle. It's like a rolled up rug right here.
Well, it looks like there's a lot of circular features in it.
Huh. I didn't think about that. Let's just go straight to Google Earth and see what it has to offer. And we got cracks of the world tied to it, so that's probably have a better idea of structure. Let's get cracks of the world turned on. Okay. This is where that big sargassum thing's developing.
Yeah, I saw that on the press is all over that thing. You know, they think it's global warming.
Sargassum.
Yeah, and they actually refer to it as sargassum.
Yep.
And it's this big bunch of red algae that was headed to the Gulf of Mexico, and it was supposed to hammer onto the
Florida.
but I think it dissipated before it got there because they're not talking about it anymore.
Interesting. Cool.
They always make a big deal out of it. And then when these things go away and take care of themselves, oh, I never, what? What are you talking
Well,
about?
so I mean, I feel like since it's cyclical like that, and it's happened before, and it may have something to do with El Nino, you know,
It might.
structurally that's totally connected right here. It's just this continent in the middle of it, which is a big deal. But I mean, that big shear envelope structure is coming right off the mid-Atlantic ridge, off the main feature
Sure.
from Africa, and you could see it bust through the continent. It certainly is affecting it, but there's this big quiet spot down here. So that shear
Yeah, well,
envelope is
that's the
going.
Amazon Craton. Amazonian Craton.
That's called the Amazonian Craton.
Yeah.
Wow. And you could totally see that. It hits that and it goes, okay, we're gonna have to figure something out here, guys. And it kind of busts off left, or what I think's going on is that shear
Well, it
envelope is
deflects, yeah.
it's wrapping around the Amazon Craton, and then it comes right into this big mess of the whole El Nino thing.
Yeah.
So my take is, man, I wonder if serpentinization, ocean floor generation, that process is just ramping up, and we're getting this big geologic plume of energy coming out of the ocean floor.
Maybe.
And then the north side of that big shear, that's the south side. This is the Texas shear. That's kind of the north side of it.
Yeah, the main Texas shear.
So when you follow that into town, that's when it starts getting real interesting. You got this massive shear that's been going through California, Arizona, New Mexico, and Texas, Gulf of Mexico for.
Where's San Antonio on this? Do you have San Antonio on this?
Oh yeah.
Should be right on it.
It's pretty close. It's pretty close. And then so when you zoom down into San Antonio now, you got the big Balcones fault region that's coming right through it.
Right, that's a Riedel tensile splay off of that Texas crack.
Riedel tensile splay. Hold on. Riedel tensile splay. This is a pretty good structure map of what's going on.
Here we go.
So this is kind of
What's the green? Is the green the oil fields?
Map of the San Antonio area showing the Austin outcrop belt in green.
Austin Chalk. Okay.
Yep. And the base of this thing is the Eagleford timeline. We're dealing with this Austin Cretaceous outcrop, and then at the base of it has this world-class oil generating formation, and this is where it outcrops across the whole Balcones fault system.
Mud volcano. If you put the mud volcanoes on there, it's almost a direct match.
But yeah, so what for sure what I'm following is that serpentine, or an ultramafic peridotite, could be getting hydrogenated, and the Balcones fault system could be a pathway of migration for serpentinization.
Yeah. Well, if you got one of those maps that you could overlay on this map, or overlay this map on the serpentine plug map.
Yeah, I got to get it all georeferenced, and I really want to get a hold of Carter actually, so I can see if he has a more detailed one that I can really match with this. He probably does. But all we do know is that when it's blue, it's that the southeast side is down, and when it's magenta, the northwest side is down. So that's the dip.
So most of them are southeast side.
Mm-hmm. Yep, but right
towards the Gulf.
Right.
Towards the Gulf.
Right, but right in here, where we're going to do this outcrop studies happening, which is, there's the loop. It's right here.
Okay, and that's one of the magenta guys.
Direct connection to this magenta one, which puts the down thrown side on that side.
So if I drive to San Antonio, which road am I going to be driving in on?
You're going to come in on the 10, so you're dropping in like that. You're coming in like this.
Well, there is a at least a gross connection between the serpentine plugs and the Austin chalk. Now, if you go to the northeast towards Austin, right up in there, you see there's a lot of Austin chalk up in
There's a
there.
lot of mud volcanism.
And
Yeah.
right on the mud volcanism. The mud volcanism is right there.
Right. Right. So when you refer to mud volcanism, you're making a distinction between ultramafic rocks.
No, just all I'm saying is that that's the top of some kind of an igneous process that could either be alkaline metaluminous things, or it could be the ultramafics. Could be either one.
Meaning serpentinization. So you
Yeah.
could have a dehydration of a metaluminous layer going on that could be making igneous rocks that look sedimentary.
Alkaline, yeah, which is type 2 oils of various kinds. Most of these are going to be type 2 oils.
Right, right. And interesting. Okay. So when you say mud volcanism, you're really referring to just like the diapirs, these features coming from the basement.
Yeah.
Okay. Got it. I just want to be on the same page with that. And man, there's some really cool stuff you're going to see when you get out here with all the guys that have some really good data out here. There's some seismic lines that have some wild features. So that's going to be really cool to see and lay out and take a look at. So that's a little bit of a structure map. There's some of the bigger.
Yeah. So it's you in 2016. Is that the paper we've got?
This is the road guide. This is a field trip guide done by, again, John Cooper, current president-elect, South Texas Geological Society, David Farrell, and then we have Thomas Ewing.
Is that the Ewing of Permian Basin fame?
Yeah.
The structure guy?
Yes. So it looks like they took all the stratigraphy and then they changed it to hang on this timeline right here. Horizontally. So that's
the Paleocene unconformity there.
Where they're hanging this
Pretty much.
Lituola.
Wilcox is Eocene.
Litiola.
Navarro's Paleocene. Where's they're showing some kind of a angular truncation of almost equivalence across some big arch, like, is that the San Marcos Arch? Yeah. So there was some active tectonics going on in the late Cretaceous. And there's Austin chalk, which is mid-Cretaceous. It's about probably Cenomanian, upper Cenomanian. And the other interesting question is, where is the Turonian unconformity?
Let's see if we can get a strat column going here.
Yeah, okay, there's your Turonian. So it's at the top of it's the Eagleford, Boston. That's interesting because regionally, that is the beginning of the Laramide orogeny.
Whoa.
That's when you start to flatten stuff.
Whoa. From the big subducting plate coming off here, going underneath all this.
Yeah.
Whoa. Yes. Okay. Eagleford is on the same timeline as a flattening slab, which is heating up the bottom of the crust.
Right. It's a major disruption in what's going on tectonically.
Whoa. How do you get serpentinization in flat subduction?
Well, I mean, near the trench, you're just jamming the ocean floor right underneath the craton. So that's what the Orocopius schist is.
Right.
And that process starts at about 89 on the Turonian unconformity.
Wow, that's amazing.
Turonian unconformity is recording the plate reorganizations that are associated with the beginning of the flattening.
All right, so if that's the beginning of the Laramide firing up, does that mean that's the beginning of India starting to make its way across?
Yes.
So India is now fired off towards China,
rocketing up towards the belly of it, southern belly of Asia.
right? Wow. And then laramide orogeny cramming in. And in San Antonio, Texas, we have what appears to be possible serpentinization coming right to surface. This one.
So if I do come out there and we do this conference, I probably want to take several days in the general area, just meeting you and your buddies, just to steep myself in all this data.
Cool. You're more than welcome to stay as long as you want, Stan. Okay, so we've confirmed through the work done out here that the Eagleford Austin boundary is Turonian, top Turonian, which means that's the beginning of the flat subduction in North America.
Yeah.
Which is coming along this slab tear and this slab tear.
Yeah.
So along this region, flat subduction's kicking in. We're getting volcanics are working their way. If it's going flat, that means volcanics are starting.
The arc effect's being shoved east.
It's coming east.
Mm-hmm.
And then it's coming along these railroad tracks, right?
Yeah, that's more or less the direction of subduction.
And then here locally at this boundary, we have potentially a dehydration of serpentinite.
Something going on, yeah.
And Eagleford pinches out over the top of this, but not completely. There's little thin.
Yeah, well, see, that's the Turonian nonconformity effect there. You'll love the severe. What's the orientation of the San Marcos Arch?
Like this.
Northwest.
There's the San Marcos Arch.
All right, so it's northwest going, okay. And then what's all that east-west thing out there going? So a continuation of San Marcos Arch or something else?
Yeah, that's what they're calling it. This continuation of the San Marcos
They're
Arch.
showing it as a sort of a monocline.
Yep. And the Eagleford is thickening drastically going this way. But it also thickens back this way.
So the mud volcanism and Austin chalk is roughly coincident. Balcones fault, you need to pose all those together.
Yeah, Balcones fault system.
So there's an interaction between, so San Antonio, how much oil is in this San Antonio?
It's no, I mean, it was San Antonio, like proper. I'm not sure. It's always been the city. It's always had the rivers. It's always had the city. But as far as south and along this Balcones fault region from Austin, now you got to stay south out of the city a little bit in Austin, but you come down through Luling and Seguin and you wrap around towards Uvalde and you follow that Balcones fault system through there. That's where largest oil fields in the state were discovered.
Right, pre-Permian Basin.
Well, just as old. I mean, the first horizontal true success story in a black mud was right here in Pearsall. They started it all. That was the first horizontal. They based on the success in that field, the Railroad Commission figured out how to actually regulate horizontal well drilling and how people actually papered up leases with mineral owners with horizontal well drilling. It was all that all started in Pearsall. And Luling is a 1 million barrel field. You go out to Uvalde, there's several 1 million barrel plus fields, and they all are associated. Not all the big ones are definitely associated with deep structures.
And these serpentine floods.
Right. Yeah, these things are popping up all through here. So what do you think the San Marcos Arch is exactly? What's coming up from basement?
Well, that northwest trend would be parallel, direct, motivated by compression coming from that'd be a severe effect. It's a severe orogeny effect.
From this, coming from this way.
Big foreland arc, yeah, that would be northeast southwest compression.
Wow.
Which is I would blame it on the subduction effect.
On the subduction coming straight this way, but it does wrench.
Causes the stress fields reorient. And then you have a different stress regime going above the unconformity, affecting Austin chalk time. And then, see, Austin chalk is the same age as the Niobrara up in
Yes.
Colorado.
And that's
Okay.
what they call this big Niobrara marine limestone marl that comes in. They call it all Niobrara.
Yeah, and they're all early laramide features in terms of what the regional tectonics is doing. Yeah, there it is.
There's San Carlos, Crevasse Canyon, Menkes Shale, Niobrara.
Yeah, once you start into the laramide, you start at this oscillatory regression where you're pushing the Cretaceous Sea in an oscillatory way off the craton. Because once that thing gets really flat, the whole craton turns into a giant super plateau.
Wow, no kidding.
Yeah,
Wow.
and you get serpentine under the whole thing. That's the driver, in my opinion, for why you get these big, the real big unconformity is the Eocene unconformity under the Wilcox. There's also a Paleocene unconformity. But the point is that those unconformities are created by an uplift effect. And what's been under thrust there? Serpentine. Well, what's that? Low density. So that changes the whole density configuration of the craton because it sticks to the bottom of the craton and pushes it up into the air.
Wow. Holy cow. So the whole area is being uplifted.
Yeah.
Whoa.
Differentially, but I mean, there's this basically this.
Wow.
The big structure of laramide has nothing to do with, you look at the front ranges and Monty gets all excited, and that's nothing. The thing that really, the biggest laramide structure is the Eocene unconformity that sits on top of the Rockies. And it comes all the way on down to where you are in Texas. If you go back to your cross section, we can bracket the laramide orogeny here. You basically take the Turonian unconformity. So you take the Austin Eagleford line.
Yeah.
Let's see, I would probably put it in Midway. Navarro
Okay.
Midway. That's a big unconformity, and that's top laramide.
So is that the point of max flattening?
No, I would actually put it in ultimate top laramide. That's a major break in the laramide. That's where they put their horizontal reference. That's a pause, and then you have Navarro Midway Wilcox. That's laramide.
So this is max flattening is up here.
Yeah.
Wow. And if you look at
in Wilcox time,
so let's go back to the cross section. Let's go back, Stan. Let's go back. Look at this thing. It goes from a big carbonate, dolomite, hydrite, like very little siliciclastics at all. Goes and then bang, when it goes flat.
Yeah, that's the Cretaceous Seaway that crawls all the way from Texas to the Arctic. The maximum deepening, which is a severe orogeny feature, is in Cenomanian and Buddha time on this cartoon. So you see that big blue thing, that prograde thing?
Yeah.
That's all severe. That's main severe.
Wow. And then when we go flat.
So you have prograde and then it becomes regression after that. And that's laramide.
And you get a massive deposit of one of the most prolific oil and gas reservoirs in the whole state from a flattening subduction event that's bringing in chemical muds from serpentinization coming from a hydrothermal perspective, right?
I wouldn't throw you out of the room if you said that. Everybody else would.
Yeah, but nobody else in the room here, Stan. Now, to take
a little microcloset, I'm fine with this.
Here's what's interesting. I wonder what the difference is of the Buddha limestone chemistry versus the Austin chalk limestone chemistry.
Be an interesting question.
because this one's a true mid-Cretaceous sea and all that, but at this point, we're
I bet the
flattening.
Buddha thing is more of a pure limestone, whereas Austin is going to have dolomitic components.
Right on. So we'll see dolomite come in here, and then we get, not sure what the Ozan sprinkle is.
I don't know either. I don't know.
The Pecan Gap, it seems like the same amount of rock, but then what do we see again is a massive, but back to bracketing your regional tectonics and how it's tied to best reservoir is Eagleford, Austin Chalk, and then second best, or maybe the first best anyway, was all this stuff.
Well, it's that transition between the Eagleford and the Austin. That's the Turonian unconformity, and that turns out to be a hell of a reservoir thing. There was probably a few 100,000 years where a thing was actually standing out of the water. There's relief on that, and it wasn't submarine relief. There was probably subaerial relief too.
Wow. And a bunch of structure. You're going to start implementing a lot of cracks and faulting at this time.
Yeah.
And then so you get this kind of rebound effect. It starts making, or it has a carbonate cap to this event.
Yeah.
So that carbonate cap comes in, and then it happens again. There's some like another surge right here of flat subduction, and we get this overwhelming, massive.
That's right. It's oscillatory. Every time you get a regressive push, i.e. an offlap sedimentologically, then indicates a little pulse of flattening. That's what we came up for our Niobrara story. We have a big story. We wound up having a whole day symposium at RMAG where we told this story.
Man, that would be fun. Let's do some correlations between.
Well, and I have all those PowerPoints and all that shit that we worked up for that.
Let's do that. Let's talk about that. Next time we get together next week, let's do that. Let's do let's bracket the timelines like you were doing. Obvious one for me is Buddha to the base, between the base of Eagleford to upper Austin Chalk or middle Austin Chalk, and then another one from the top of Pecan Gap.
Well, yeah, basically on that, if you were to just superimpose the orogenic epochs on here, I would put in, that whole thing is severe, but there is a big sedimentological shift there at about 112, which ironically at 112, 113,
Yeah.
that's the same age as the Alberta tar sands based on the uranium osmium dates.
So right at
And then
here.
it's severe all the way up to 90, and then it's laramide from there. But then there's the big Paleocene unconformity at 65. That's global. So that is the flattening part. And then the flat part is going from Maastrichtian through Eocene. So you kind of have a flattening laramide scenario, and then you have a flat laramide scenario.
Wow. Wow, that's freaking cool. I thought it was going to have what I was looking for, but it's not what I was. It's like that, but it's a vertical one. So
well, that one is another one. We did a big project on Chamas in north central New Mexico.
So this is a cross section from Pacific Ocean through California, Arizona, New Mexico to Colorado.
Yeah, Kansas, Nebraska. So north of Texas. You notice that
And
Texas.
Top of
Yeah.
Laramide. This is the Green River Formation.
Yeah.
Is that
That's
Niobrara equivalent?
No.
Niobrara's down here somewhere.
Yeah.
There it is.
The name should be in there.
Yeah, it's this. You got a green stringer from New Mexico into Colorado at that Niobrara time.
Yeah, that's Niobrara timeline right there. Yeah.
Which would be
Austin.
the Turonian timeline.
No, it's Coniation Santonian. It's the first two stages of laramide. It's 90 to 80, basically.
It's right here.
90 to 80 is Niobrara timeline.
Okay, so so would you say that the Niobrara serpentinite, so the Niobrara work that you guys did has a tie to serpentinization, correct?
Yep.
Would you say that that's actually base of Austin or upper Eagleford?
It's mostly Austin.
Oh, wow. That was one of my questions when I first saw
What's
this thing.
below there, down Eagleford timeline and up in Colorado would be the Graneros black shale. And the base of that whole succession up there is the Dakota group.
So you put
Sand.
the Eagleford equivalent rock right at that unconformity,
Yep,
and that's a black shale.
yep.
So what I'm
Graneros.
my major takeaway from this call today, which we're just going to wrap up and get ready for the next one, is that the formation we're looking at out of that crop, that
That is the Turonian unconformity you're looking at.
this one, this wavy
Yep.
line, which means the rock that we were just looking at, which is maybe serpentinite, is base of Austin chalk.
Roughly the Eagleford Austin contact. I mean, obviously there's some relief on that and all that shit, but yeah, that's what you're going to be looking at.
Wow, son of a gun. Cool. Son of a gun. Okay, we're gonna do that. We're gonna bracket this stuff and compare it to the work you did in the Niobrara, and get a big regional idea of what the real timing of all this is. But I'm definitely following. You got basically a big scale stuff is that there's a flattening, there's like a flattening push through this part of the laramide. It's not a real steady, like, there's something going on. It's like a
No, it's
pulse.
incremental. It's very
And then
incremental.
And then there's a big push at the end.
But all that blue bar there, all that transgressive stuff there, that's
This stuff,
yeah. What do they call that? Let's
reefs and shoals.
yeah. See, that's all a severe feature.
Wow. As it's trying to ramp up and flat subduction is coming in.
Yeah, a big reef system that rings the Gulf of Mexico. That's all severe timing.
So we're going from
Nobody believes this shit. Thompson's dead, man.
Nobody believes this shit.
What?
I do. No, you're like, yeah, no one believes this shit. I do.
Well, we're dying off.
Thompson's already passed away.
Yeah.
So what you don't have is the plate the subduction setting before this one. You would have it a steeper plate, and then you flatten it, and then maybe it stays like that for a while. That's what makes
That's what my 78 paper did.
In the same timeline?
Yeah, it anticipates all this stuff where basically I came up with the idea at about 89 million. Coney's number was 80, but after looking it over in detail, I came up with 89.
Okay.
And via the stratotectonics. And prior to that, it was constant dip. And that was the plate tectonic configuration for severe orogeny. And then it was variable dip, flattening in this case, for early laramide. And then late laramide is the flat subduction phase.
So
And that coincides with things like the Green River Formation, the serpentine plugs in Arizona.
something like that.
Yeah. Well, that's early laramide flattening, and then you have the really flat laramide subduction, which goes on. Move that first one up to 65, because there's kind of a pause there, and then it really hammers in.
Okay.
Yeah, right there. Yeah, move the middle line up a little bit.
This one?
Yeah. Right there.
And the description on the left here is how are you explain this is your thesis. This is the variable dip, variable rotation of subducting plates. What do you call this? Like
Yeah,
tracking?
variable dip flattening in the 90 to 65 one. And the other one is constant dip. Yeah, this is fun because I've never applied it to this exact part of the world, but it's a nice fit.
Ah, yeah. Yes, it is, Stan, and it makes sense to my brain.
Yeah, but all those guys at San Antonio are gonna look at you like you have four eyes. Because you're going against a belief system.
Well, they
See,
always
when
said,
people get to the belief system level, it's almost impossible psychologically to crack.
well,
So that's severe variable dip flattening. Move that variable dip flattening sign down to the between 70 and 90.
all right. So you got the constant dip that's coming through here, and then you got a flattening surge, and then a variable dip flattening that makes the rest of
And
this.
then flat subduction, say above
Yeah.
that, which maximizes in the slab segments to the north at 50.
Okay. Well, this is cool because you can get serpentinization with flat subduction and while it's
And
going
Steve,
flat.
the
And Steve,
main thing is that you're playing around with some kind of an ultramafic source in the mantle, which in the deeper mantle is the QA, NA, and MA time sources, and then the calcic source one for the flat subduction.
so
The CA and the AC are different styles of alkali calcic and calcocalic eclogite sources, I think.
right. Yeah, depleted eclogites, isn't it?
The
Are they
farther up you go, the C is depleted. No, the C is depleted peridiotites.
depleted peridiotites, eclogites?
Okay, so if you want the two types of eclogites, for the calcocalic, it's high alumina eclogite. And for the alkali calcic, it's a diopside eclogite.
Wow. What the heck? High aluminum eclogite and diopside eclogite.
See, I've got a lot of serpentine color up there right next to the trench affecting the calcic layer.
Yes. So serpentinites and serpentinization is happening under the continent, and it's happening in
Yeah,
the
when you go flat, you move that little green thing all the way out into the Denver plus.
with this wedge of green out here.
Yeah, that gets way out there.
Wow. Holy smokes.
During the
And
flat subduction.
so if that's true, then where are the big volcanoes coming in that are true metaluminous alkali
The
calcic?
Austin chalk stuff, that's coming from quartz alkalic.
Yeah, where's that? That's got to be on the same timeline, but just out towards Mexico. Those mountains must be coming in at that timeline, right?
They are.
So where are those mountains at?
Chihuahua fold thrust belt.
Really? Where's that?
Okay, you see the Rio Grande there coming up towards El Paso?
Yep.
And all those mountain ranges to the immediate southwest of the Rio Grande are part of the Chihuahua fold thrust belt.
Wow, that's Austin timeline equivalent volcanics.
Yeah. Yeah, you'd have to go back to Barker's. Barker has an excellent take. It's the volcanism in West Texas is a little younger than that. But it's
That
alkalic.
is freaking wild. So that's happening up here, while San Antonio over here, the Eagleford and Austin Chalks going nuts. Let's see if I got the cracks of the war. Yeah, so that's in between that slab tear and this slab tear is the Chihuahua Mountain thrust.
Yeah.
And right here in San Antonio, along that same subducting plate, we got Austin Chalk and Eagleford depositing. Draw this one.
Now,
Yeah,
where did you do that elevation profile? Was that north of the slab tear?
that's along the Balcones fault system. So I went
Oh,
from Waco down this real low
wow.
prof. Yep. And then I wrapped around the Rio Grande and went into the south side of the Chihuahuas. And that's where that is, right there. So that's the south side of the Chihuahuas. And this is San Antonio. So just trying to get a better, like a better drawing of what's happening there topography wise. But the other one that's interesting is the Permian one, which is this guy. This and which lines up with a big crack of the world. Let's just run it like down through there or something. See that big crack right there?
Mhm.
Runs right along that guy. And that's the big shear that there's the Texas shear we've been talking about. And when it does that jog, the Woodford and the Permian Basin just lights up like a Christmas tree. It's this huge gas deposit. And you guys just didn't have the data, I guess, to put the gas there. But if you did, it would be along that big crack like that. And then it goes onto this side of the Delaware Basin. And then if you come down the Permian Basin one, you hit these mountains down here, but this is just a big down, just a slope down. So
Where
that's
does
pretty
the crack go through? Where does the slab tear go through?
right here,
Yeah, where is that on that section?
right there.
Right at the topographic low.
Mm-hmm.
Now that's interesting. Totally different topography behavior north and south of that slab tear.
Oh yeah.
Wow.
Yeah. Can't get much more obvious than that.
No, and then where's the next slab tear?
This guy down here.
Yeah, is that on that line?
Yeah, and on the other side of it, it goes flat again.
Yeah, so put those in.
It just basically, yeah, it's binding the major topography.
That's pretty cool.
Yeah, it is. Yeah, it is. So there's a big connection there, and hopefully our next event is we really want to dive into more of this slab tear coming through the Permian for our Permian Basin show. But right now we're in San Antonio. We're gonna focus on it, and we got a heck of a opening storyline going on here, Stan. I like it.
You're dangerous.